I really apologize for not being able to communicate with you in your language. And I also want to thank the organizers of the event for inviting me to participate. It's really an honor to be here. You are our neighbors, and we have to learn about you. I know the image you have about Spain and cannabis use in Spain is not accurate. Recreational use is widely spread in our country, but medicinal use is not regulated. And we are suffering, and especially patients. So the more we can learn from our neighbors all over the globe, the better for us. And I'm going to take the liberty to say that I'm extremely happy today because we have kicked out our president from the government. And I really hope, I'm just saying this not because I want to share my political views with you, but because I think this is going to be good for the movement. I think now, with a different government, we will be able to talk about medicinal cannabis with the government. And that's the only reason I'm mentioning this. Well, I'm going to try to explain you what we have been doing in the lab. And when I say we, I'm not talking about our group only. There are many groups. In Europe, there are a bunch of them that are doing very good research on the anti-tumor potential of cannabinoids. And before starting presenting some scientific results, I'm going to start with this slide where I want to show you what cancer is. Because if I ask you what you think cancer is, you will say it's a tumor that grows, or cancer cells that grow without control. And that's only part of the picture. So I want you to have a complete idea of what cancer is, and that's why I prepared this first slide. So in the top part of the slide, I have a cartoon of what this, can you see the pointer? Yes, perfect. This is a cartoon of how the disease progresses with time. This is the first part that we all know as cancer. We have few cells that acquire mutations, genetic mutation, and they start growing without control. And this is what generates what we call tumors, the tumoral masses. But this process is also accompanied by the generation of new blood vessels. Right now, and please don't get scared, we all have tumors, but they are very, very small, and our bodies can get rid of them very effectively. And one of the reasons is because this process of providing new blood vessels is switched off. But in oncologic context, when we have cancer, we activate this process that is called angiogenesis, and these growing tumoral masses have an extra supply of food that allows them to grow. And this is process, when we are targeting cancer, we have to take into account that this process has to be tackled as well. And at the final stages of the disease, what we call metastasis, a few of these cancer cells are able to escape from the tumoral masses. They get into the circulation, they travel, and they reach distant locations when they generate new tumoral masses, which are more aggressive than the primary tumors. And in fact, metastasis is the main cause of cancer-associated deaths, more than the primary tumors. So this is what we see when we think about cancer patients. But you have to keep in mind that cancer patients have to deal with other things, like the side effects produced by the anti-tumor medicines they take. These include, and I'm just naming a few, nausea, vomiting, lack of appetite, pain. These are things that we, if we are healthy, can deal with very easily. But think about suffering all these things on a daily basis and how these impact your quality of life. And we have to also consider the psychological aspects of the disease. When one is facing cancer, is dealing, again, on a daily basis with anxiety, not only his or her own anxiety, but his family, his friends, her family, her friends. They are all suffering anxiety, trouble sleeping, and again, this is having a huge impact on the quality of life. So what I'm going to try to do now is answering from the scientific point of view many of the questions that we receive from patients. And I want to stress out that I'm not a physician. I'm a doctor in biochemistry, so my patients are mice. I don't treat actual patients. So my answers will come from what we know from the labs, from the scientific labs, not from the clinics, although I will make a couple of mentions to results coming from human studies. But I want you all to know that I'm not a physician. So the main question we receive is, I have cancer, can cannabis help me? And the answer is absolutely yes. Is cannabis the cure for cancer? The answer is no, but cannabis can help cancer patients for sure. And cancer patients can benefit from cannabis because we have an endocannabinoid system in parts of our body that are involved in this first slide I showed you. For example, we have an endocannabinoid system in the parts of the brain and the gut that control nausea. And if we have an endocannabinoid system, we can modulate its activity with phytocannabinoids, with THC or with CBD, and modulate this physiological response. So we can use cannabinoids to block nausea and vomiting. We can stimulate appetite with cannabinoids because we do have an endocannabinoid system in the parts of our body that control hunger perception or hunger feeling. We can use cannabinoids to control pain because we do have an endocannabinoid system in the parts of the brain and the spinal cord that control pain perception. We can control anxiety, sleeping, because we do have an endocannabinoid system in the parts of the body that control these physiological functions. And we also have an endocannabinoid system in cancer cells. And that's why we can modulate the viability of cancer cells by using cannabinoids. And after more than 2 decades of research, preclinical research, we know that cannabinoids can block the 3 stages of the cancer progression that I've mentioned before: uncontrolled cell proliferation, angiogenesis, and metastasis. And I'm going to show you a couple of examples of proving what I'm saying. So regarding the first part of the disease progression, uncontrolled cell proliferation, we have accumulated millions of pictures like the one I'm showing you here. This is one of the first experiments we conducted in the lab in the late 1990s. And these are glioblastoma cells growing in plastic plates in petri dishes when we don't treat them with anything. And these black spots you see here, these are cell nuclei. Each of these spots is pointing to one cell. And this is how cells look when they are happy and healthy in culture. And what you see on the right is what happens to these cells when we treat them with cannabinoids. In this experiment, we use THC, a small amount of THC. And as you can see, these 2 pictures are strikingly different. Here, we can hardly see any cells in the plate, and the ones that are remaining are completely different in shape. They are round, they are refringent, and they are detached from the plastic plates. And all of these are signs of death. In other words, we are killing cancer cells with cannabinoids. And when one sees something like this in a cell culture, the immediate thing that has to perform is an in vivo study. There are many, many things that kill cancer cells in petri dishes, but not all of them work when we move to a more physiological setting. So when we saw these results, we decided to move to an animal model of cancer. And the simplest one we can use in the lab is immune-deficient mice, where we inject cancer cells underneath the skin, in the back, in the side of the mouse. And they have to be immune-deficient because what we usually inject is human cancer cells. So to avoid rejection, we use immune-deficient mice. So we generate these tumors, and if we let them untreated, they look like this. This is a brain tumor in the back of a mouse. And when we treat these animals with cannabinoids, in this experiment, for example, with THC, we observe a striking reduction in tumor growth. These 2 things here are the tumors. This tumor is this tumor, and this tumor is this tumor once they have been surgically removed. And you can see the difference in size. And I think it's pretty obvious that there is another difference that has nothing to do with the size. It has to do with the color. Here, you can see that the tumor is red, meaning that it's full of blood vessels that are providing food to this tumoral mass. But on the right-hand side, you have a tumoral mass that is completely white. It means that it doesn't have any blood supply, and this tumoral mass is not going to grow beyond a certain size because it has no way to receive the food. So we are impacting not only tumor growth, but also angiogenesis. But again, when one thinks about a brain tumor, we don't have brain tumors because someone comes and injects us here in the back, brain tumor cells. So we move to a more physiological setting, which is generating the tumors in the same location where the tumors appear, in this case in the brain. So we injected these brain tumor cells inside the brain of rats, and we generated these tumoral masses. These are MRI scans, the same tests that actual patients go through, and this white mass here is the tumor. And when we treat this rat with THC, the tumor completely disappeared. But again, we don't get tumors because someone comes and injects us cells in the breast or in the brain. And we were lucky enough to have access to another animal model, in this case of breast cancer, where the tumors appear spontaneously. We have to do a genetic manipulation when they are very, very small, when they are in the two-cell state. And as a consequence of that manipulation, when they reach puberty, the females start developing breast tumors spontaneously. We don't have to inject anything, they just show up, and only in the females, like in the human pathology. And we treated these animals with cannabinoids, and what we saw is what I represent in these two graphs. Here we represent tumor volume, the size of the tumors, versus time. And as you can see, the tumors grow exponentially. And when we treat these animals with THC, you see that the growth is dramatically decreased. But not only that, we also saw an impact on angiogenesis, as I mentioned before. For the sake of time, I'm going to skip this slide, but the message from this one was again that we are targeting not only uncontrolled cell proliferation, but also angiogenesis. And don't forget metastasis. We need drugs that effectively target metastasis, and cannabinoids seem to be one. In the case of these animals that I mentioned before that generate breast tumors spontaneously, they also generate metastasis spontaneously in the lungs, as in the human pathology. So in the control group, the group that didn't receive any cannabinoid treatment, we had almost 70% of the animals with these kind of lesions in the lungs. But when we treated the animals with cannabinoids, with THC, less than 20% of them developed lung metastasis. So we are tackling uncontrolled proliferation, angiogenesis, and metastasis with the same tool, with the same therapeutic tool. What about human results? Do we know anything about the anti-tumor effect of cannabinoids or cannabis in humans? Well, unfortunately, we know very little. The only controlled clinical trial, high-quality clinical trial that has been performed so far has been carried out in hospitals of the UK and Germany. It was completed a little more than a year ago. The results are not public, unfortunately, but the company that sponsored the study, GW Pharmaceuticals, put a press release in their website giving a summary of the results, which is shown here. In this study, they recruited 21 patients, GBM, glioblastoma multiforme patients. 9 of them were assigned to the placebo group, and 12 of them received temozolomide, which is the standard treatment for these kind of patients, together with Sativex. You all know that this is a cannabinoid-based medicine that contains both THC and CBD. And what GW says that the results are is that the 1-year survival went from 53% in the placebo group to 83% in the group that received Sativex as well. The median survival was roughly 1 year in the placebo group, and it went to 550 days in the group that received Sativex. And something that I think is very, very important for us, and especially for doctors that are concerned about the side effects of these cannabinoid-based medicines, is that the number of patients that discontinued treatment because of side effects was 2 in the placebo group and 2 in the Sativex groups. group. In other words, whatever made these patients discontinue the treatment had nothing to do with Sativex. If you put this not in numbers but in percentage, the number of people leaving the trial was even bigger. The percentage of people leaving the trial was even bigger in the placebo group. There were side effects, of course. It would be naive to think that we have a medicine that has no side effects, but there are things like vomiting, dizziness, nausea, headache, constipation. If there are oncologists here or patients with cancer, I think it's very clear that we're dealing with a medicine that is quite safe. So another question that we receive is, would cannabis work for my type of cancer? Because most of the research has been done in brain tumors and breast tumors. And people contact us with all sorts of tumor situations. We don't have an answer, of course, because we don't have studies in humans, but again, from the lab, from the preclinical setting, this is what we have so far. We have demonstrated anti-proliferative effects in a lot of different types of tumors. The list is smaller when we talk about anti-angiogenic or anti-metastatic effects, but it's not because in the other types of tumors we haven't seen these responses. It's just because we haven't studied these responses in the other types of tumors. So I'm sure that this list will increase in the following years, only because we will start studying these two processes in other different types of tumors. So far, it seems that all cancer cells share something that we haven't identified yet that makes them susceptible to be treated by cannabinoids. Another question that is very important for patients and for doctors is cannabis safe? Are we talking about a safe tool? And starting from the preclinical setting, from the lab, the answer is yes. We have conducted many experiments in cell cultures comparing how tumoral cells are affected by cannabinoids versus non-tumoral cells. And this is just an example. In this experiment, we used a number of different cell lines, breast cancer cell line. Think about a cancer cell line like a breast cancer patient. So it's like if we had studied different breast cancer patients. Blue and green bars are different breast cancer cell lines. And here we represent cell viability. And that means the percentage of cells that remain alive in our cultures. So we want the bars to go down. We want to kill the cells. And as you can see, when we treat them with cannabinoids, all the blue and green bars go down. But there's one that doesn't go down, the yellow one. And these cells are not tumoral cells. These are healthy mammary epithelial cells. In other words, cannabinoids kill cancer cells, but they do not affect the viability of non-tumoral cells. And we've seen this in brain tumors, in liver tumors. The cancer cells die, the non-tumoral counterparts, they don't. What about in vivo? What if we work with animals? Do we see toxicity at any level? The answer is no. Every time we do an animal study, we collect all the organs of the animals and we send them to a pathologist, and we've never seen any sign of toxicity whatsoever, no one. And what about humans? Do we have any clue whether these compounds are safe for cancer patients or they represent a danger that we should avoid? Well, apparently, again, we don't know. We don't know because we don't have studies performed in cancer patients specifically designed to answer this question. But we know that many studies have been conducted in cancer patients, and I'm showing this page because you can go to this site, clinicaltrials.gov, where all the clinical trials that are ongoing are registered. So this information is public and accessible to all. And I have found, and this was updated a few months ago, more than 500 clinical studies that has been already completed with patients that have received cannabinoid-based medicines. And none of these studies have shown that cannabis-based medicines are toxic or dangerous for the patients. Another question that we receive is, what kind of cannabis do I use? And this question is very wide. This applies to THC, CBD ratios, and many other things. But I want to focus on one specific question. Is it better to use pure cannabinoids, or is it better to use whole plant extracts? All the experiments I have shown you so far have been performed with pure cannabinoids, but not because we think that's the best therapeutic option. Remember that we are biochemists, and we are a cell signaling group, so our goal is to understand how cannabinoids work. And if we treat our cells or our animals with a whole plant extract and we see a response, we will never be able to assign this effect to a single component. We will never know which was the responsible of that effect. So our goal is to understand how THC works or how CBD works. And now that we know, we want to know if combining them the way they are in the plant, together with the other components of the plant, is a better therapeutic approach than using the isolated compounds. So to answer this question, we established a collaboration with this company based in Australia, Cell Therapeutics, and we compared the anti-tumor efficacy of pure compounds, specifically pure THC, with that of a full plant extract provided by the, let me see if I can say it, non-profit mutual benefit corporation based in California on Celdas. So this extract contains THC, of course, and other compounds that we have tested, other cannabinoids, other terpenes. So if we see any difference in the effect between these two drugs or compounds, it will be due to these accompanying compounds. And we decided to test these two therapeutic approaches in different models of breast cancer. We use the same word, breast cancer, for a lot of different pathologies. Breast cancer is a very heterogeneous disease, extremely heterogeneous disease, but oncologists make the treatment decisions based on the expression of 3 proteins. And according to that, we recognize 3 different subtypes of breast cancer. The first one is called hormone sensitive, because these tumor cells have estrogen receptors or progesterone receptors. How do oncologists treat these patients? Well, with hormonal therapy, which is the aim of this therapy is shut down the estrogenic signaling. How can we do that? We can either remove the endogenous source of estrogens, the ovaries, or we can use drugs like tamoxifen that block the estrogen receptors. We have a second type of breast cancer that is called HER2 positive. HER2 is a protein that is overexpressed. Overexpressed means that we have more amount than normal in the tissue. And the medicines that are given to these patients are specifically designed to target this protein. They are called anti-HER2 treatments. And one of them is a molecule called lapatinib, and I'm just mentioning this one because I will show you some experiments performed with this drug in a minute. And then we have a third type of breast cancer that is called triple negative, and this name comes from the fact that it doesn't express estrogen receptors or progesterone receptor or HER2, and that's why they're called triple negative. And since there is nothing to target, there is not a protein that is specifically upregulated to target, these patients just receive chemotherapy, the standard chemotherapy that I'm sure you all know that target all the cells in our bodies that are undergoing proliferation, either tumoral or not. And it's very easy to understand that these treatments are very, very toxic. So we started by doing in vitro experiments in cell cultures, and we treated the cells either with pure THC or with the extract. And we observed, first of all, we are representing here cell viability. Again, we want the bars to go down, the lines to go down, versus increasing concentrations of THC. And as you can see, both approaches decreased the viability of cancer cells. hormone-sensitive breast cancer cells. So we are killing this type of cancer cells by using either THC or the extract. But the most interesting part of this experiment is that the purple line, the extract, goes below the green line. And this means that the extract is more potent in killing cancer cells than the pure compound. We have done this experiment in other hormone-sensitive breast cancer cells, and the results have been exactly the same. What about HER2-positive breast cancer? Exactly the same result. Both THC and the extract kill this type of breast cancer cells. The lines go down, and again, the purple line goes below the green one, saying that the extract is more potent than the isolated compound in killing cancer cells. And what about triple-negative breast cancer cells? And I'm not showing you the result now because I want to stress out before and remember you that there are no targeted therapies for these patients. So if the results are positive, it will be huge for this breast cancer subpopulation. And what we have seen is that cannabinoids kill this subtype of breast cancer cells as well. And again, the extract, the purple line, is more effective, more potent than pure THC in producing this effect. We, of course, moved to the in vivo setting because things can work in a way in cell cultures, and when you move to an animal model, the result may be completely different. And what we did in this case was injecting cancer cells in the back of these little mice, and we treated the animals either with THC or with the extract. I don't know if you noticed, but I rarely put doses or concentrations in my slides because I don't want anybody here to go home with those numbers and go to internet and search for the weight of a mouse and then make a conversion. If a mouse weighs 25 grams and I weigh 70 kilos, I have to take 3 grams of THC a day. Please don't do that because mice metabolism and the cannabinoid system are different than ours, and you will have, in the best of cases, a very, very bad trip. So don't do it, and that's why I never put doses. But in this case, I left these numbers here on purpose because I want to stress out that we used exactly the same amount of THC in both treatments. So if we see a difference, it's not because we use a different amount of THC, but because of the things that are accompanying the THC in the extract. That's okay. So we injected the animals with the cells, we left the tumors grow until they are small, and then we started the treatment. And this is what we observed. And we did these experiments in, this is hormone-sensitive breast tumors. And we see this is tumor volume. Sorry, this is missing. I'm sorry. This is tumor volume, the size of the tumors. And this is time. And as you can see here, the white dots represent how tumors grow when the animals receive no treatment. The green line is how tumors grow when they receive THC, pure THC. There's very little difference in growth. And this is the effect that the extract produces. So again, as in vitro, the extract is way more potent than the pure compound in producing antitumoral responses. What about HER2-positive tumors? Exactly the same response. This is the white dots are tumors that receive no treatment, a slight antitumor effect produced by THC, and a huge antitumoral response when we use the extract. And what about triple-negative tumors? Do we see the same thing we saw in vitro? Well, we did. I don't have the results, sorry. I don't have the results because the experiment is not finished. The last measurement of the tumors will be done on Friday, so that's why I didn't have the graph ready, but the results are exactly the same. Both THC and the extract decrease tumor growth, and the extract is more potent than the pure compound. So another question, can I combine cannabis with my other treatments? And I'm very happy that these questions are the same ones you pointed out before. So these are the questions that patients and doctors have. So we are trying to give them tools to answer them. And this is a very important question, of course. And one more time, we don't know because we don't have studies coming from human subjects. But the preclinical research suggests that it's a very good idea not only not quitting standard treatments, but combining them with cannabinoids. Just a few examples. There are many different approaches to treat cancer, many different chemotherapeutic approaches. One of them is using what we call anti-metabolites. This scheme here is our genetic material, DNA, and we can provide cancer cells with pieces of the genetic material that are slightly modified so that the DNA duplication is not made correctly. And when this happens, the cells detect that they have a problem and they commit suicide. So there are a bunch of compounds that belong to this family of chemotherapeutic agents, 5-AU, capecitabine, funny names, not important, but this is an approach that is very widely used in the clinic. And there are examples that combining compounds belonging to this family with cannabinoids is a better therapeutic option than using either of them alone. In this example, this is a colorectal cancer model, cell culture based, and this is the effect that 5-FU alone produces. Here we want the bars to go down. We are killing cells and we are representing the number of cells that are still alive, so we want the bar to go down. And this is the effect that the chemo compound produces alone. This is the effect that the cannabinoid produces alone. And this is what happens when we combine the chemo compound with cannabinoids. We can kill way more cells than when we use each of the other approaches alone. This is another example. There are other family of chemo compounds that are called alkylating agents. They incorporate a chemical structure into the genetic material, so the duplication of DNA again fails and the cancer cells commit suicide. And in this case, these experiments were performed by my colleague Guillermo Velasco. They perform experiments with temozolomide, the same drug that has been used in the clinical study by GW Pharmaceuticals. And they combine temozolomide with THC. And this is an in vivo study. This is the behavior of the tumors that do not receive any kind of treatment. The tumors grow exponentially. This is the anti-tumor effect of THC alone, of temozolomide alone, and this is what happens when you combine both treatments. So I think it's very obvious that combining, or at least from what we know from mice, combining chemotherapy with cannabinoids is a better idea than using either of them alone. I'm going to skip this one. What about radiotherapy? A lot of patients, not only breast cancer patients, receive this kind of treatment to treat their tumors. And there are also animal studies showing that combination of radiation with cannabinoids gives better results than radiation alone or cannabinoids alone. Again, we are representing tumor volume, the size of the tumors. This is how they grow when we don't treat them. When using these doses of cannabinoids, and when I say cannabinoids here, it's a mixture of THC and CBD, we produce a small anti-tumor effect, irradiation, small anti-tumor effect, and when we combine both things, you see that tumors hardly grow. Again, the take-home message is don't quit your standard treatments. Combine them with cannabinoids, but don't quit your treatments. What about human studies? Do we have any human studies showing that there is any negative or positive interaction between standard anti-cancer treatments and cannabinoids? The answer again is no. The only clinical trial that has been performed to answer that question is the one I mentioned, promoted by GW, and we don't have the results yet. But there are many studies that have been done in cancer patients, not to see if there was an interaction between drugs, or not to see if there were an increase in the anti-tumoral responses, but to see, for example, if cannabinoids work for their pain. And there are many, many studies that have been conducted with that goal. And those patients were receiving their anti-cancer treatments. They didn't quit their treatments to enroll these clinical trials with cannabinoid-based medicines. And none of those studies, and there are many, have shown any kind of negative interaction between the treatments. More questions. What cannabis strain do I use? Ratio, THC, CBD. How much do I use? How do I take it? Route of administration. We are working on these things in the lab, and we will try, we'll do our best to provide tools to answer these questions. But we need to do studies in humans. I can spend the rest of my life in the lab doing experiments with mice, but if we don't move to the human setting, we will never have the answers we're looking for. And finally, please, this warning sign. There are a lot of good people out there trying to help patients, but there are a lot of people out there trying to make money out of patients. So please, if you have doubts, go to reliable sources of information. Go to the original sources of information. So just to sum up, we have a lot of preclinical proof that cannabinoids work as anti-tumoral agents in preclinical models of cancer. Now we have proof that the whole plant extracts are more effective than pure cannabinoids to produce these responses. We also know that they are safe. They produce side effects, of course, but they are safe medicines. They synergize very well with anti-cancer treatments. And don't forget that they have additional advantages for cancer patients. They are analgesic or appetite stimulants, antiemetic, and many more. So what are the next steps? As I said before, we will keep working in the lab trying to answer all the remaining questions. We want to know more about the mechanism of action. The more we know, information is power, also in oncology. The more we know about how these compounds work, the better we can use them to target cancer cells. We want to know more about how these compounds combine with standard therapies. We have many, many questions to answer. And we have work, I will retire and most of these questions won't be answered yet. But what we need now is clinical information. It's information coming from patients. And that information can come, of course, from studies like the one GW has conducted. And we need those studies. We need studies coming from big pharma companies. We need them. But in the meantime, we can do something to help patients. We can collect information, and I think this is critical. There are thousands and thousands of patients all over the world that are using cannabis. If we know how much THC and CBD were given to the patients, and if we take the effort of collecting their clinical information, and I'm not talking about how do you feel, I'm talking about scans, I'm talking about blood tests, I'm talking about doing a rigorous follow-up, like the same thing you would do with another medicine. We are talking about a medicine that belongs to the allopathic medicine. I don't see it different. It's not an either or. This is part of the medical toolbox, and it has to be treated the same way. So let's do clinical follow-ups with the patients that you guys are treating. That's the take-home message for me. Thank you very much. Merci.